Hello, it's Duncan. I don't usually start these videos with a title in mind, or even in fact a teaching goal. I'm basically just producing content that I would watch, something that shows how one reasonably proficient developer approaches problems. One thing that I hope comes across is an emphasis on living with the decisions that I take, because real-world projects can't be restarted when they run into technical issues or changing requirements. So it's interesting to see how a JSON parser has been refactored, after one full start, from something that largely works but is inefficient and unsafe, to quite tight production code with error handling. Today's episode is largely consolidation. I really like it when a project gets to this stage, when new features are easily implemented in terms of the abstractions that are already in the code. This may not be the pinnacle of JSON parsing technology, but as an experiment in whether the application of TDD can solve computer-sciencey problems, I think it's proving a success. I think we'll start as usual with a little review and tidy. So here is our top level parse function. It takes a char sequence that we're assuming is JSON. And we're starting with this top level ground. And we are progressing the top level ground parse state through other states depending on the character. This top level ground accepts quotes at the beginning of arrays or objects, white space or characters from literals, and otherwise it complains. Looking back up, there's still something irritating about the fact that we're keeping a list of values here, but at our top level we can only return one. But we can't use a nullable variable in that situation, because null is a valid value for us to return. So overall I think the only harm in this is that the mutable list we create here will have spare capacity. We drill down through mutable list of, that ends up in array list, and this will end up in a Java array list, and I think that has an initial capacity by default of 16, just off the top of my head. So I think we could probably do just slightly better there by saying this is array list of any with an initial capacity of 1. Just check that's okay. And it is. And we're reasonably certain that we never add more than one thing to it, because here we check to see whether it's not empty before we add. And even if there was to be an item in here, then this value single would have thrown, and we haven't seen that in any of our tests. So that's a very minor efficiency change, but probably worth keeping. Also here though, I'm seeing that we've got this illegal argument exception with no message. So let's go and see where we test that. And it's right at the top here. If we test an empty string, I suppose technically an empty or blank string, then we throw an illegal argument exception. And I think we could say the message should be equal to what? Maybe no top level content found. We'd like that to be true for all of them. Put that there and there. Check that we weren't already doing that, and we weren't. So our message was null and not no top level content found. So we'll remember that message and put it in there. Good. Now if we did manage to get more than one value here, then this value single would throw, but the message from that would be list has more than one element, which is a bit cryptic. So I think maybe we'll go in here and say when values dot size not equal to 1, then that's an error, and there should be unexpectedly found more than one top level value. And given that our state machines seem to be working so that we never have seen a place where this throws, I don't have a way to test that, but it means we'll get a better error message if we ever do mess it up. Okay, moving down the file, this add value from, I think we'll probably take out of here and just move down to the bottom, paste in there, and then go back. Now the valued interface is probably less fundamental than the parse state, so I think I'm going to take that and just move it down there. Don't think there's such a thing as a private interface. Oh no, I'm wrong, that's a little bit tidier. But I think it's also true that our parse state could itself be an interface. So instead of being an abstract class, I wonder whether we can refactor that. It doesn't look as if we can. We could extract an interface, but I think the easiest thing to do is just to say private interface parse state, and then fix up the places where we're using the constructor. I just learned how to delete right. after all these years. Right, run that. Good. Back to the beginning. And next we have our top level ground, which is a ParseState, and this is what allows us to fail early if we have invalid characters at the top level, but otherwise moves into string state, ArrayState or ObjectState, or into a literal. Moving on down, we have ground. Now that ground I think is only used in our object parsing at the moment. We'll come back to that. There's literal. That accepts characters until it finds a separator, so that's comma, colon, or white space. And I think actually for symmetry this could be ground except char. That's true. Not sure whether symmetry is worth it, but I'll leave it in. And a literal is the first of our ParseState that actually has a value. We can ask it later, and that depends on the contents of the string inside it. It's either null, true, false, or might be something that we can parse as a big decimal. A little blank line there we can get rid of. String state, we still have some work to do around escaping things other than a quote, but otherwise just collects things into a string builder. And here is our array state that we worked on last week, and we found it very helpful to have an array ground that was different than our top level ground. There it is down here, and that allowed us to use this seeking comma state, which in turn was a way of making sure that our array elements were separated by a comma. And they're also a good way of making sure our error messages are good in context. Okay, now down to ObjectState, and this is as yet unimproved by our better sense of how to do collections. And indeed it's still collecting ParseStates rather than values, and the problem with that is that it means that we could have a large object full of things that didn't actually make sense yet, but we'd only find out when the object was complete and we come to ask its value. That's here where we iterate over the states and go and get their values out. So I think the first thing I'm going to do is fix that, and we're going to try and make our object state look like our array state. So to do that I'm going to split this file so that we can see two versions, and we'll work from the array state on the left hand side. Let's put it there, and the object state here. I'm going to try and make these look as close together as we can. So first of all, we have a ParseState in both cases, but they've got different names. So I'm going to give this one the name state, and let's pull that is complete down and check that's okay. Well, that's unsurprisingly okay. And as with the object state, we're going to keep a list of values. So we'll copy that and we'll put that to here. And now we want to be putting things into that value. As with the array state, we want to be putting them in when our state changes. So we can copy this code here, I think, and put it in there. And when we're done, we need to be accumulating a value as well. So that's that line there, which we're going to put into there. Check that hasn't broken anything. It hasn't. And now that we're collecting all the values, down the bottom, in the case of the array, our value was just the values we've been collecting. In the case of the object, here we were going to the states, but now I think we can go to the values. They won't be valued because they will actually be the values. So we take that out. And I don't know why that was called 3 states. Sounds like a bit of a hangover, but we're going through the values and they should be a string, a value, a string, a value. So that's why we're going through 2 by 2. So this should be actually key and value, and they should now actually have their values rather than us having to go and get them. Get rid of that and that. And if we're right, that will still pass the tests. Oh, it does. That's good. And that means, I think, that states, while we're adding to it there, I wonder if we take that out and make that unused and delete it. Does that still pass? Yes, it does. That's good. Little blank line there. And I think that will be a good place to check in with tidy and make object state fail quickly. Commit that. Good. Okay then. Now, object state is still suffering, I think, with this windowed. So we're now collecting values. The first one of which we're expecting to be a key as a string, and the second one we're expecting to be some sort of value. But we really haven't looked into the error messages from our object state. First one of those actually is this one here. is complete. We're not putting anything in here. I think for the array we said something like unterminated. Ah, there we are, unterminated array. Let's just write ourselves a test for our objects. We have one there, look, already. So let's copy that and we'll write ourselves a test for unterminated objects. Looks like I hit the wrong quote there. And this should say message is equal to unterminated object. Run the tests. They fail as we expect. And let's take that string and put it into the right place in here. Does that make things good? It does. I think there are a few more of our tests around unterminated arrays. So, there we go. So let's copy those. Because they have a bit of white space around them. Just going to put. So that's equivalent to our first one. So I'm going to take these and put them in here as well. So had we had that or that, and I think probably we should put in something which is going to be a valid object. So we'll start with triple quotes. It's really annoying when IntelliJ does that, isn't it? 2, 3, and here as well, 2, but not those, and then those, and this is going to be a string colon banana unterminated, and then maybe a string colon banana. I've already lost our triple quotes on the end, but I'm going to put a comma in there and like that. That should be object, as should that. Run. Okay, good. Now then, what about badly formed objects? Going to write a test. Badly formed objects. So what sort of things do we expect to find? Well, I'm going to copy this one into here and say that if we started with a literal, say true, and then, I don't know what, some sort of otherwise reasonable identifier, and finish our object, then this shouldn't be unterminated object. It should be something like, I guess, unexpected. What did we say in arrays? We said, oh, well, here we've got unexpected character in an array. I think we can do better, but let's just remember the form of that. I think ideally we'd be saying here, expected a string key in array, not, in this case, the T for true. Now, obviously that will fail, as we expect. And what we're getting is Boolean cannot be cast to string. Now, why is that? Let's have a look. And the answer is that we've got our key value pairs in our values, but here the first thing was the literal true that we tried to cast to string here, and that's why that's failed. Now, there are all sorts of other ways that arrays can fail, and I'm going to record a few of those while I think of it. So maybe we'll duplicate this line and just try things like, we know that if we got a key, triple quotes again, so we know that we got a key and then something else without a colon, that should be an error. Don't know quite what error yet. Maybe we'll just duplicate that into here and not worry about what the message is. It would also be an error to say have a key, colon, and then end. It would also be an error to have a key and a value of, say, 42 and then a comma and the end. And we could go on, but I think that will do for now. And also for now, I think I'll just get the first one parsing in some sort of way, which, remind ourselves, it isn't at the moment. Okay then, back to JSON. And I think what we'll do is use our experience from the arrays to allow us to set up more states to get better error messages. So reminding ourselves back in arrays, we had this array ground and seeking comma. And at the moment, though, in object we just have ground. Let's go to there. And this ground is only used in our object now, so I can take it out of here and put it into ObjectState. I'm going to put that down here. So what sort of states can we be in within an object state? I think the first state we'd be in is looking for a key. So I can call this seeking key. Once we've found a key, then we're going to be looking for a colon. So I think I'm going to call this seeking colon. Now, once we've found a colon, we are going to be looking for the value. That's the other side of it. So let's duplicate this, and we'll have an object that is seeking value. And then before we can go back to seeking key again, we will be seeking a colon. So again, duplicate, and we'll call this inside here seeking colon. Okay, so in our object state, we're going to start in seeking key, and we want to finish in seeking key as well, I think. Now then, seeking key, what are acceptable characters? Well, in fact, the only valid characters when we're looking for a key are white space, in which case we're still looking for a key here, or the quote that will take us into string state. So I think we can get rid of that, and that, and that, and that, and say else. And what was our error message? It was expected a string key in array, not something. So let's use that in here. And this is throw illegal argument exception, not, and this is our char. This string state, though, doesn't want to go back to seeking key, it wants to go to seeking colon once it's done. Okay, now seeking colon, what do we accept? Well, we could accept white space, in which case we're carrying on looking for a colon. Otherwise, when we find a colon, we're going to go to seeking value. And everything else is illegal. So we'll take something like this, and we'll say expected a colon in, that should be object. Fix that one, and go and fix our test while we remember object. Okay. When we're seeking a value, what are we going to allow? Well, that's all the normal things that a value can start with. So that is our quotes and our brackets and so on. We won't allow a comma or a colon. We'll allow white space. But all of these things, when they're done, don't want to go back to seeking value. They want to go to seeking comma. And seeking comma, I should have renamed that. So seeking comma, seeking comma, seeking comma. And now seeking comma, what do we allow? Well, as with the colon, we allow really only a comma or white space, so that none of these things are allowed. In the case of a comma, well, then we're seeking a value. Everything else is expected a comma. Now, colon and comma as actual states are no longer required, it seems. And there's just a chance that that will work. Let's try running the tests. Okay, let's have a look. Objects has expected a comma, not curly brace. I suspect that our end condition is not right, so let's go back here. And here, when we get a bracket, I suspect we should be allowing ourselves state is seeking comma. And in fact, we can only really be seeking the key if we are empty. We'll write a test for that in a minute. If this passes, well, we seem to have moved on, so let's go and look here. Okay, this is a nasty test because we're using curly braces inside our quotes for our value. But given that's worked up above here, I suspect that this is our issue here. It's saying expected a comma in our object, not a colon. Let's go back and we'll just check our logic. So we start in seeking key. We can end in seeking key or seeking comma or literal. We're still expecting our values to come out as a string and then the value. That's all good. Okay, seeking key. So we're only looking for a quote, in which case we're going to a string state that should seek a colon. That looks good. Seeking colon. When we find a colon, we should be looking for a value. That looks good. When we are seeking the value, when we find something value-like, we'll go into that state, which should then be seeking a comma, and then seeking comma. Here, look, when we find a comma, we should go to seeking key again. Is that good? Phew, that's good. So now we can go back to our tests and say, well, these should pass. Let's have a look, see how they do. Interestingly, something key equals 42. That's not actually going to tell us where our issue was. I think it's this one here, which is where we expected we'd have an issue. So this trailing comma will put us in seeking key, but we can only end in seeking key if we're empty. We had a similar thing with arrays. Let's see what we did there. So that's the case like this one here, where we failed with unexpected character in array. So let's take that, see whether we can say that in there, and that would be unexpected character in object, and that is the terminator at this point. And I think we can make that work by going here, and as with our array, let's have a look for that. So in our array we had is completable, and we were only completable if we were seeking comma or we were ground and we had no value. So let's do the object equivalent of that. So we'll put that in here, maybe. So this is object is completable, and it is that I finish on a literal, or I'm in seeking comma, or our equivalent here is seeking key. Take that and put it in here and try. And in fact the error message we get is expected a string key in the object, not our bracket. I think that's probably good enough to use as our error, because we've gone through the comma and hence we were looking for a key. Run, and we pass. Now what about the message in these other cases? Let's see what we expect to get. Here I think we do expect a colon in object, not the for. Is that true? Goodness me, yes it is. And how about this case? Now here we're looking for a value, but we end up with the curly bracket. So I don't know quite what that's going to say, but let's put something in and see whether it's good enough. What we get is one too many quotes. Run this and see what it actually says. The answer is, it says unterminated object. Well, that's interesting. I wonder how we got there. I think for now I'm going to say that that is a thing. Let's get it parsing. Yeah. And now why do we get unterminated object here? Well, I suppose it's because the object isn't completable. Well, a little bit of investigation, I think I've come to the conclusion that the issue here is that we were in seeking value at this point when we got this right bracket, but we weren't completable, so we passed the right bracket through to seeking value, which in turn passed it to literal. So I think the issue here is that seeking value, instead of always passing to literal here, should, as our array did, check that the character is valid for a literal. So that is this line here. I'm going to copy those two. So seeking value should say those two things. But if we're valid in a literal, we give a literal. Otherwise, we are an unexpected character in our object. Run that. And that now gives us a better error message here, I think, that the right bracket was unexpected. Here. And run. Well, that's good. Today's been quite short and sweet, so let's take the energy I have left and use it to just review JSON.kt. I think in our new way of thinking, informed by the state machines inside the arrays and the object, the top level ground we could rename to be seeking value at the top level. Other than that, I think we're doing quite well there. There's our seeking value. Literal is still good, I think. String state likewise. Array state, well, we've called this array ground, but I think again this could be seeking value in the array. So in the array we are either seeking a comma or we're seeking a value. And then we have a similar but more complicated situation in an object state. I think there are a couple of error cases here in value which we haven't actually found, and the states that we might not be able to get into, but if we did, we'd maybe want better debug. So the first is, what happens if our key and value isn't a string? And our state machine should be preventing that from happening, but in case it doesn't, I think we'll say, let's use as question mark string. We know it can't be null, but if it's not a string, then we want, that would be an error, and this would be key in object, and let's actually give it its value, is not a string. So if we do mess up, that will give us some idea why. And secondly, we are assuming that key and value's length is 2. Now it must always be 2 because this windowed here, we're not allowing partial windows. But if we did allow partial windows, so we'll say partial windows equals true, then in here we could check and we could say if key and value size is not equal to 2, that means we've had an odd number of key and values. It's obviously not good for us, so that would be an error. Something like didn't get both a key and a value only, and I think we'll assume there must be at least one thing in there, so we will again use that. It's always a bit of a risk writing error messages for behavior that you don't know how to provoke, so this is just best efforts at the moment. But we check that it doesn't actually break anything for the happy path by running the tests. Splendid. And then just sanity check the rest. Seeking key, looks good. Seeking colon, looks good. Seeking value, looks good. And then finally seeking comma. Wonderful. So I'm going to check that in with much better error messages for objects. I think now that the only thing that makes this not a proper JSON parser is that our string state doesn't process some special escapes. They're documented here on json.org, so we should fill those in. I say I think that's all that's required, but I also think that we need to do more verification. I think we have pretty good tests on the whole, but it would be good to fuzz test the inputs that we do have, which is to say generate more examples from the ones that we have, and also find a test suite online that might have examples that we haven't thought of. So that will be our job for the next episode. If you'd like to see that, then please subscribe to the channel if you aren't already, like this video to help the algorithms, and maybe even buy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.